Welcome, everyone, to the Mapped Out Podcast, Episode 1. Let's go. I am your host, Michael Patterson, along with my co-host, Michael Szymanski. How are you doing today, Michael?
Good.
Well, today we have an awesome episode for you guys. We're talking about sleep, and in particular, melatonin, and our opinions on it. We'll give you the science behind it, and then we'll tell you how our opinions are shaped by science. So without further ado, let's dive in. Okay. Michael, today's episode is on sleep. But before we get to it, we got to do one more thing. Guys, if you like the episode, if you think that you find value in our topics, bring them up in conversation. It really helps us out, helps us grow naturally, and we really appreciate it. So, without further ado, now let's dive into the topic. Michael, today's topic is sleep. It's kind of a complex topic, especially for college students and probably older individuals as well. But before we start talking about melatonin and possible solutions to sleep, I think it's important that we outline what sleep actually is. So can you give us an overview of the sleep process?
Yeah, for sure. So, sleep is divided into two categories. We classify them as non-REM sleep or REM sleep. And the term REM just means rapid eye movement. This was derived from when people, scientists specifically, studied patients who were sleeping in these stages and noticed when their eyelids are closed, there was still very fast horizontal movement of the eyes. So that's where rapid eye movement came from. So we have non-REM and REM sleep. And then non-REM sleep is the first category of sleep, and it's divided into stages. So this is stages 1 through 4. And as the stages become larger in number, that signifies that it's a deeper period of sleep. So 1 is the first stage that we go into, then 2, then 3, then 4, and then it's a REM sleep. So stages 1 and 2 are the lighter forms of non-REM, and then stages 3 and 4 are the deeper forms of non-REM sleep.
Okay. And so what is the timeline around that? So now we understand the stages. Is there a particular flow that they go through?
Yeah, so it varies from person per person, depending on, if you want to go on specific time stamps for these stages, but usually it's within the 30-minute time cycle is stages 1 and 2. Then you will drop down into stages 3 and 4. And then near the end of the 1 hour and 30-minute time cycle, which is a usual cycle of sleep in studies at least, then we will reach the REM sleep cycle, which is the rapid eye movement.
Okay, so let's dive deeper into that rapid eye movement portion. Could you explain a little bit about what happens during the rapid eye movement? Obviously, our eyes move rapidly. Wow, we're getting scientific here. But could you explain to me some of the health benefits, some of the logic behind getting REM sleep?
Yeah, for sure. So the first thing is that it's the principal period of sleep where we dream. So obviously everyone knows what dreaming is because we all do it. Most of us, at least. Some people don't. It also contains periods where we formulate memories and we learn things by tying stuff together. Like concept weaving is a way I like to describe it. So an example would be the man who developed the periodic table. He had flashcards of every element, and every day he would throw them down on a table, try to see if they had some order to them. And then one day after a nap, he obviously was in REM sleep probably, and he weaved together the concepts, and then the periodic table was discovered.
Wow, that's super interesting.
Yeah, so aside from weaving memories, it's also where growth factors are released. So these are just chemicals that are important for healing, cleaning, and the reinforcement of specific regions of the body. If you're working out and you're sore, growth factors are released to that area to relieve soreness. Neurotropic growth factors, the neurons of the brain, stuff like that.
So really, I think REM is the textbook cycle of repair,
Yeah.
and where a lot of the stressors and everything else that we put on our body during the day gets healed up at night while we're sleeping. And I know we're going to dive into melatonin. We're going to go into the science behind melatonin and what it does to the brain. Could you outline, right before we get there, REM is often on a certain timeline in the night. Could you explain that a little bit?
Yeah, so as I mentioned before, sleep scientists use a 90-minute cycle. This has been derived from a cycle named ultradian cycles. These are natural cycles that us humans go through. So that they noticed every 90 minutes they saw this pattern of stages. So that's how they derived this through sleep studies. So it's a 1 hour and 30-minute cycle. And near the end of the cycle, we see the REM sleep that we're talking about. But then as we progress through the night, the ratio of non-REM to REM, it changes. So as we go further into the night, we see more REM than non-REM. And this is crucial relating to melatonin use, because as we'll talk about later, melatonin is on a certain wave of how it's released gradually through the night. And that relates to how REM sleep is also, the ratios of REM sleep is also increased over the night.
Okay, so it's as you progress through the night, REM becomes more evident later on in the sleep timeline.
Correct.
And so I think this is also crucial for making sure that you get enough sleep, right? Because whether you're on melatonin or not, the time that you spend sleeping is important. And having that wherewithal to realize that, hey, I need to get an X amount of time, because that way I can reach my REM, reach the repair cycle, is crucial. So are we ready to dive into melatonin?
Yeah, sure, why not?
Okay, so let's talk about melatonin. What is melatonin?
Well, melatonin is a hormone. Most people think it's a synthetic chemical produced by companies. However, this is a hormone released in your body naturally by the pineal gland. The pineal gland is a gland that is in between the two hemispheres of your brain. Most structures in the brain are bihemispheric, meaning there's two copies of them. However, this pineal gland, derived from pine cone, because that's what it looks like, not literally, it is in the middle of the brain, near the back end. And this specific structure releases the hormone melatonin.
And so we're talking about hormones, right? Hormones are crucial to brain development throughout our growth and continuation into, and then they continue into when we go into adulthood. So when we take hormones, right, that does impact our brain, and it's pretty crucial, especially during college when we're still in that development stage, that we understand what taking a hormone does. So could you go into a little bit about how it affects development, and I think even a little bit if we're younger, because I know some people start in high school when they're still developing in puberty. Could you talk a little bit about that?
Yeah, so little known to many people, and this is not their fault, is that melatonin actually has a second function in life, and that's to suppress puberty. So as we usually think of a regular melatonin cycle, it's biphasic, meaning it runs inversely to the phasic cycle of cortisol. Cortisol being released in high amounts in the early morning, which makes you rise, and then melatonin being in a lower level, comparative. And then in the inverse, when we're looking at the night, where cortisol is low, melatonin is high, so you get this sudden sleepiness that we usually notice. But anyway, when you're a young baby, this melatonin is not only released in the evening, but it's chronic tonic release, meaning that it's not at super high levels, but it's still released at high levels throughout the day, which is opposite of what we see after people cross the age of puberty, when they're done with puberty, that is. So we see the cyclic period of the biphasic structure start to come into the realm after puberty, but we see this tonic relationship where it's a gradual release over the entire day for pubescent and prepubescent people. And the point of this is that since the pineal gland is in location to other brain structures that are regulating homeostasis and hormone secretion, since it's released in such high amounts throughout the day, it suppresses these hormones involved in development.
So,
and I have to mention that this is a correlative study. So I'm not trying to say that that melatonin is specifically suppressing these hormones, but in science, as we can see correlative relationships, then we can start to conclude something. So it's purely correlative that this biphasic structure after puberty is realized alongside the release of these growth hormones.
Interesting. So diving off of that, I really want to understand we understand how it works throughout the night and throughout the brain. When we look at, let's say we take melatonin before we go to bed, what happens, or what are the symptoms, but what's the outcome of us taking it? And then you even mentioned that because you took it, right?
Correct.
That you would wake up around 3.5 5 hours into your sleep. Could you go further into that?
Yeah, sure. So as I was talking about the biphasic cycle, when we look at a normal sleep schedule, let's say 10 p.m., that person puts their head on the pillow, melatonin will not be in high amounts. Melatonin is more so secreted in its highest amount, the peak amount, usually midway through a sleep cycle.
So not in the beginning.
Correct. So if we use logic here, we're taking a very high dose, which I'll go into later, of melatonin as soon as we not really start our sleep cycle. So our brain recognizes this as not literally, but that we're more so less in the middle of our sleep cycle when we're not, because we just put our head on the pillow. So this is maybe a reason why I deducted that people may wake up earlier than usual, because your brain as cortisol rises and melatonin decreases, then you'll obviously wake up. But if you're starting at that high peak, if people can imagine a curve, then you're starting at that high peak, so then you'll end up at an earlier time period waking up.
So, yeah. So whereas originally your brain thinks, if we're looking at a big hill cycle, right? Your brain naturally wants to start at the low end, work its way up, and then come down. But when you take melatonin, it starts at the top. And so it registers as, oh, I'm at the top, I am ready to come down now. And you end up waking up because your body's like, oh, I'm nice and refreshed. But in fact, you didn't have that front part of sleep. And I think this ties back into REM, right? Whenever you cut that timeline down, and REM doesn't have the time, right? Because it comes later on in the sleep cycle. It leads to less repair and all the things that come with that. So you mentioned a little bit there, dosage. Dosage is important. Talk a little bit about dosage.
Yeah, so usually in a bottle, it's usually a 5 milligram or 10 milligram dose of a gummy or a capsule. And they did experimental testing on this being these people being nutritional scientists, and they tested melatonin brands that were sold in stores. We won't out any, but basically what the study concluded is that the range of what was actually in the pills versus what was listed ranged from anywhere from 15% of what was listed up to 400% of what was listed.
Oh, geez.
So basically what this means is that this stuff is very unregulated. And for reference, as we mentioned before, melatonin is a natural hormone produced by the pineal gland. And as with other things in the body, we aren't releasing supraphysiological levels, meaning above regular conditions of the body. So the pineal gland usually secretes around the nanogram range. And for my non-scientific people, that's a 9 decimal point decreased from the standard 1 gram, going backwards, not forwards, meaning that we are taking maybe a billionth of a time more stuff than we need.
So basically, that is a sucker punch to your brain.
Correct.
Oh.
Yeah.
Yeah, you don't want that. You don't want that.
And it doesn't take an economist to see why they do this. Obviously, they're increasing the dosage to get a harder punch to people so that they buy their brand versus another brand.
And I think this stems back to, if we're pulling out of just melatonin, in general, right? Your body adapts to whatever it comes to use and whatever you put into it. And when you give it a sucker punch and you do it regularly, I know people that take it every night because it helps them go to sleep. Over time, right, that can have effects. And our goal here at the Mapped Out Podcast is to just give science and say, hey, here's what we think about this particular topic, and hopefully it can help influence your decisions. So let's say somebody listens right now, and they go, man, I don't want to use melatonin anymore. What are some other opportunities that I have throughout my day that I can help my body know when to fall asleep, and I can improve my sleeping in general?
Yeah, so the first thing I always recommend is that if you're planning to come off a certain supplement, whether that is a certain drug or a supplement like melatonin, then you should slowly decrease your dose as you want. This usually meaning if you're taking 5 milligrams, maybe take 3/4 of the capsule, then a half, then a fourth, and then a fourth for a couple of days, and then none. This will teach your natural production to start increasing again, because obviously if you're taking a hard sucker punch to these specific areas that naturally release this hormone, they will not be as active as they were before. So you have to reteach this cycle of releasing the hormone again. So you want to not go cold turkey like most people do, because your brain will not be taught how to re-regulate that process again. So usually gradually decrease your dosage if you're planning to come off a certain supplement, so that your natural production can start increasing.
It's just like training, basically, where you can't go out and go absolutely marathon, triathlon, etc., hardcore in the beginning, right? You have to work your way up to it.
Yeah. They work in both directions, yes.
Exactly. So now, once again, the person has said, hey, I'm off of melatonin. What are some tips that we have?
Yeah, so the first one is that you want to wake up at the same time every day.
Why is that crucial?
Yeah, rather than going into sleep at the same time, because in my opinion, waking up at a certain time is takes way more discipline. Then you're already tired late at night. You can push that off pretty easily.
Yeah. Welcome to college.
Yes. So another reason I want to state waking up earlier in the day is for the purpose of sunlight, sunrises. This is because there's a certain mechanism in the brain where if the rays of light from the sun hit the retina, which are cells in the back of the eye, those cells will project back to the suprachiasmatic nucleus, which is just located in the far back part of the brain near the pineal.
So that will be on the spelling quiz, I take it?
Correct.
Okay.
And what this does is it actually sets off a clock of melatonin release later into the day, usually a 16-hour window from when sunlight was viewed. So by doing this, preferably from 15 to 30 minutes, obviously not directly looking into the sun, I do not recommend that, without sunglasses, without a cap on, walking outside, maybe viewing it outside of your window or through the window, or if you wake up in the darkness, turn on as many overhead lights as possible. Basically, this will set off a 16-hour time window in which melatonin will be gradually released up until the period of time in which you want to go to bed. So it kicks off this cascade of action so that you don't have to do as many things at night. Rather, you can just do most of them in the morning.
So as soon as you wake up, your body's already planning on when it's going to sleep. And by waking up early, not necessarily early, at the same time, your body gets into a rhythm. And it says, okay, I understand that this is the time that I usually wake up. Awesome. And it feels like it has it under control. And that way, when you start to go to sleep at night, your body's already prepared because it understands the timeline that it's supposed to go through in order to get you in the mindset to go to sleep, right?
Correct. And using that sunlight is a powerful trigger for that. And you can use alarms within reason. It takes, I think, 23 days to form a habit, I believe. Some bro science term. But what I've noticed is that I use alarm for a week or a week and a half to 2 weeks. And then after that, I don't have to use it anymore. And I can just wake up on that time. So, yeah.
See, I am a 2-alarm person where I know that first alarm, I'm going to look at it and go, yeah, I'll hit the snooze. And so I always set another alarm that's about a minute off. And that way I'm not back to sleep yet.
Yeah.
So I hit snooze and then boom, I'm like, oh, and I got to walk across the room and everything. So that's in the morning. Is there anything at night or in the evening?
Yeah, so another thing I recommend is viewing sunsets.
Oh, the girlfriends are going to be happy about this one.
Correct. Yeah, so you're learning science tools and advice for your girlfriend. Anyway, so when the sunlight from a sunset hits your eyes, it hits these melanopsin cells. This is derived from the term, not literally, but melanin, like melanin, the color of your skin. Certain melanin cells, different between people. And sunlight hits these melanopsin cells and it triggers the circadian clock to know it's nearing the time for sleep. Circadian clock being another rhythm that determines many bodily functions, including sleep. And for those who like to stay up at night, watching videos, playing video games, studying, viewing this sunlight near sunset also downregulates or prevents some of the bad effects of blue light. This has been studied in that viewing this sunset, around the sunset time, this sunlight, it desensitizes these melanopsin cells to blue light. So, yeah.
So watching sunsets not only helps you in your relationship, it also helps you when you're gaming. That's what I'm hearing.
Yeah, it's a free version of blue light blockers.
Wow.
Yes.
You're learning something new every day here, guys. So is there any other supplements or anything like that? Because now we've talked about some of the natural ways. Is there any other supplements that you personally take or that you talk about in conversations when people say, hey, how do I get better sleep?
Yeah, so to preface this supplement discussion we're about to dive into, a funny joke that a neuroscientist told me is that when someone asked what a drug was, he said a drug is a substance that when taken will produce a scientific publication. So
ha ha ha, man, that's a good one. Wow.
So this is basically referencing that almost anything you take will have some effect on your sleep. So obviously there's a billion things I could say, but what I'm going to reference are things that have worked for me very effectively, and since I have taken melatonin in the past, I can reference that as a relationship to see the difference. So for supplements, I take 400 milligrams of magnesium glycinate, glycinate, magnesium glycinate. Dane. So basically,
didn't realize we also had a spelling bee.
Yeah. So glycinate is derived from glycine. This is amino acid in the body, and specifically glycine works as an inhibitory neurotransmitter in the spinal cord and brainstem. So basically what this does in simple layman terms is that it shuts off many neural firings of the neurons and stuff like that. So if you're finding yourself twitching around or you can't lay down and relax, this may help you. And then the other supplement I take is 200 milligrams of L-theanine, Theanine, 30 minutes or so before bed. That meaning putting my head on the pillow. And if you ruminate a lot or you can't stop making yourself think, then this may help you out. It's important. This supplement's cool because it's also being incorporated in a lot of pre-workout supplements to ease the effects of caffeine and other stimulants.
Yeah, so my personal pre-workout, the brand that I use, uses this.
Correct. So Yeah, so like you can use that as reference for what the supplement may do to you independent of a pre-workout. Um, Basically, supplement companies, what they do is that they use a supplement L-theanine in their caffeinated pre-workouts because obviously the caffeine punch, most of them having 200 to 300 milligrams, is pretty hardcore, and obviously you don't want to be feeling that for the next couple hours. So what L-theanine will do is slowly decrease that effect of the caffeine and make you more relaxed after your workout is finished.
So it helps you like taper off?
Correct.
Gotcha.
Yes. So this is interesting, side note, because supplement companies are putting L-theanine in this pre-workout mix for a reason. This is because that, caffeine is a drug, as we'll talk about later, and it's very highly addictive. So by putting this L-theanine in, we can lessen this effect of the caffeine while still having that strong effect at the beginning of when you took the supplement. Therefore, in theory, if you have this L-theanine, you might want to take more of this pre-workout to feel more of an effect once you become used to the pre-workout supplement.
Mm-hmm.
So they are using this for a reason. It's not just to make you more relaxed.
Oh man!
So yeah, it is playing with your circuitry to make you buy more of their supplements.
That's super interesting. No, that is, I'm learning something new every day. That's really interesting, and it actually shows how sometimes companies can, without us noticing, right? Even nutrition companies can slide stuff in there, and when you start to break down the science behind it, it becomes super interesting.
Yeah. And all these suggestions should be taken up with a medical care provider.
Yeah.
As a side note,
we are not doctors.
Correct. Always start by fixing your nutrition first, then your sleep schedule, then view some light in the morning and at night, and then you can touch the supplements.
Exactly. I think a lot of people, and through our own experience with being in gyms and stuff like that and fitness, a lot of people are instantly rush to supplementation. And when people come to me and they say, hey, how do I, if I want to lose weight, right, or I want to get leaner, etc., what do I need to focus on? And usually their first focus is like protein, right? They want to buy the protein powder, they want to buy the pre-workout, and it's like that stuff helps later on down the road. But if your sleep is not right, then your nutrition and training will be off. So you need to get your sleep right first, because that's where once again, like we were talking about with the REM sleep, that's where all the repairs, that's where all the connections are made, right? And so sleep is crucial. After that, it comes nutrition. So nutrition, what goes in your body is how you'll be able to perform. It's fuel, right, for your body. And a lot of people neglect that, right? And I know it's really hard in college. So then it becomes nutrition, and then it becomes training, and it becomes doing quality training. And we'll dive into this in later episodes. But we mentioned it a little bit, caffeine. So a lot of people, that first one, right, that sleep. So they don't get good sleep, and then we'll dive into nutrition as well, but a little bit. So they don't get enough sleep, and they're tired, and they didn't reach that REM, right? They're not refreshed. And so they grab a bunch of coffee, pre-workout, etc., fill in the blank here with caffeine. So what is caffeine? Because I had somebody when I was talking about melatonin, they said, well, isn't it like caffeine? And this person was actively taking melatonin. And no, I don't want to at them. But I think it's important that we differentiate between a hormone and a drug, right? So what's the difference between a hormone and a drug really quick? And then let's dive into caffeine.
Yeah, so a hormone is basically any substance that could be derived from a natural production of a gland in any animal. So we have synthetic hormones, and those are derived from natural hormones that were originally discovered in organisms. So that's how we derive them. A drug, however, could be and usually is a synthetic chemical derived in a lab or from a plant substance. It has powerful effects on physiology. So, yeah, a drug.
And internal versus external, basically.
Yeah, pretty much. Yeah.
Okay. So caffeine.
Yes.
Let's dive into a little bit of caffeine because that is probably the most addictive drug in the U.S. for sure.
Mm-hmm. Yeah.
And it's pretty popular. I would say most addictive drug in general, but it's pretty popular in the U.S. So let's dive into caffeine and talk about caffeine a little bit.
Yeah, so caffeine's a stimulant, first of all. It stimulates stuff, and it's a stimulant of the central nervous system. Central nervous system is just your brain, your brainstem, your spinal cord, basically your head and spinal column, your thorax, that area. The central nervous system is very important because the nerves around your periphery, that meaning your arms and legs and stuff like that, they dive from and to the central nervous system. So if we're attacking the center, then we know it's going to be important. So it's obviously, as you said, it's the most widely consumed psychoactive drug in the world. It's legal and it's also unregulated, as we can see by double espresso shots. And caffeine's also engineered chemically, or it's by extraction from plants. And as a side note, plants, they use caffeine as a defense chemical, actually.
Really?
So if you're a plant, what do you want? You don't want your offspring or possible offspring to be eaten. This will be fruit, seeds, aka. So you develop chemicals so that when the animal's scourging around and trying to eat your fruit, it has to get through you first. So then when this plant is eaten by this animal in a high amount usually, this has a lot of caffeine compared to what a little leaf would be in our coffee cup. And then it can cause a lot of harm to that animal and prevent it from eating that fruit or the seeds of the offspring of the plant.
Wow, that's super interesting. I did not know the history on that.
Yeah, so it's very deadly at high quantities, but at smaller quantities, like how the usual quantities that people drink it at, then it's not that harmful, but it does have that neuropsychoactive effect of stimulating our brain, the sympathetic drive, making us focused.
And I think that's why most people take it in the morning, right? They're on their
Correct.
way to work. And by the way, I am not saying that everyone needs to cut coffee. Like, I drink coffee probably a little too much. But it's important to understand what goes in your body, right?
Correct.
And so there are negative effects to caffeine, right? So you're it's the morning, you're on your way to work, you grab yourself a cup of coffee, you're on the way to work, okay, you drink that one, then you're at work, and then maybe you have another one. And then maybe a little later on, you're getting a little tired because you didn't get that sleep, right? So now you're drinking another one. Next thing you know, you have 400 milligrams in you. So talk a little bit about some negative effects of caffeine.
Yeah, so obviously the first one and foremost is anxiety. It can cause anxiety, and this is just because of the upregulation of the sympathetic nervous system, sympathetic being the opposite of parasympathetic, which is rest and digest. So sympathetic is drive, the system that is activated when we're in stress or need to get going. And so by upregulating this nervous system, we're always wired, so it may cause anxiety because you don't want to be always in that state. You want to be resting and digesting at certain times of the day, obviously in sleep. So it can also cause digestive issues because it interacts with the gastrointestinal tract. This could be seen when people have acid reflux after drinking coffee. I know I have in the past.
Especially on an empty stomach.
Correct. Yes, that's another topic of destroying the gut lining, but we won't go over that. It's also highly addictive because it interacts with the limbic system. The limbic system is obviously a connecting point between dopamine and the stress system. This is cyclic structure in the brain through the use of dopaminergic neurons that release dopamine, and all this I'm trying to say is that it's very addictive. It works very well with the limbic system, so it releases a lot of dopamine. Obviously, you're increasing your sympathetic drive, so it hits another structure in the brain, and since these two work in a circuit, you're hitting all of them. So it's obviously a very addictive chemical in that regard.
And I think this also comes back to, we'll tie it back to sleep and melatonin. Your body is always wanting to reach homeostasis and always wanting to reach that that balanced level. And so what happens is our intake through nutrition, right? And this would be included in nutrition as well. Our intake fluctuates that, right? And so as our body has to adapt to what we put into it, there are side effects And those can either be really good or they can be really bad depending on what we need, right? I'm not saying don't drink coffee because it has negative side effects. There are good side effects of that as well, such as memory and decreasing fatigue and all that stuff. So it's important to understand, hey, what you're putting into your body is important. With sleep, right, to understand what the goal of your body is. So if your goal is to go to sleep, would you drink coffee?
No.
Right.
Of course not.
Exactly. Now, I will say this. I'm a little weird in that sense. I can drink coffee. This tells you how, I guess, my body has adapted over time. But I can drink coffee and go to sleep right after, and it's no problem for me.
Yeah, and that plays. There's two levels to that. So your body can adapt to the coffee, meaning that the certain receptors involved with the coffee are either not being activated as well, or you could have just had a genetic predisposition to not have these receptors. So even though you do have this ingestion of caffeine, it's not acting on as many receptors as another person next to you.
Mm-hmm.
So it wouldn't have as strong of an effect.
Oh, that's...
So yeah, these receptors are called adenosine receptors, and basically, in super simple terms, we have a receptor that binds adenosine, and adenosine builds up throughout the day. And basically, when this adenosine binds to this receptor, it takes up its space and causes a downstream effect in the cell, and this is what causes us to become sleepy. What caffeine does is it's competitive. So it wants to get into the receptor before adenosine, and it does. So caffeine will act as a competitive blocker and will bind to this receptor, and then adenosine can build up but not bind to the receptor. So this is what is common in the crash after drinking caffeine.
That's exactly what I was going to ask. So explain this crash side effect.
So we have the caffeine bound as a competitive blocker in the adenosine receptor, and it will degrade over time, just as if you have something, you're pouring water over a sandcastle, and it will degrade over time. So the cell obviously is doused in lots of different liquids, so caffeine can be degraded. And when this happens, adenosine wants to get in there because it hasn't been in the receptor. So it's like, I want to get in. So it'll heavily impact these receptors and bind to them with high affinity, want to get in there, and it'll cause that large, in this case, rather than gradual, if you didn't have caffeine, have this large effect of making you very sleepy really fast.
That's super interesting. Wow. See, even I'm learning something new every day. Welcome to the Mapped Out Podcast, though. I mean, come on. This is knowledge driven. Okay. So now that I want to recap what we've done so far. So we've talked about what sleep is. We've talked about melatonin, right, and how people use it and our interpretation of the way the drug or the way the hormone is taken and the way that people use it currently and what it does. Then we talked a little bit about caffeine and some confusion around caffeine. I want to touch on a little bit towards the end here because we're all talking about, this is really about energy level and about when our body is sleeping and when it's repairing and when it has to be turned on. And I know one part that we talked about was nutrition when it came to the parts of training the parts of health. And so eating before bed, right? This intake of calories, and we'll go into this further on another episode because let's not dive into it as well. But for somebody who says, listen, I'm taking control of what I intake in my body, but they want to get better sleep, is there a certain suggestion maybe that you have when it comes to food right before bed? Is there anything around that?
Yeah, so first of all, I want to say that I do not recommend eating at all immediately before bed. So this is in the 30-minute time range.
And why would that be?
So you want your systems to be focused on sleeping, not digesting. Your neurons not only innervate all of your brain, but they also innervate your gut lining. So obviously they'll be active, releasing hormones and secretions to digest the food. So by logic, if you want to focus on something, why not turn off something else? So I don't recommend having anything in the gut, including water, because water, if you ingest a lot of it, may increase the likelihood for you to be woken up to go to the bathroom.
Really?
So,
well, I understand the bathroom part, but typically I always thought, oh, okay, I can just, because I drink a lot of water personally. And so if I don't have my water intake where it should be during the day right before I go to sleep, I just chug water. And so you're saying that's maybe not the best thing in the world?
Yeah, probably not. Yeah, I wouldn't suggest it. And for a side topic, yeah, water intake, that should be gradual throughout the day. Also, it's important to balance that with electrolytes so as to not dehydrate yourself unintentionally by drinking pure water, since electrolytes move out into the water, since it's osmosis is another subject. But anyway, so water intake throughout the day rather than before bed. Same thing with food. Food intake can be throughout the day unless you like to fast like me. But if you want to play the nutrition into sleep, push your carbohydrate intake near bed. Carbohydrates usually produce this sleepiness feel as insulin binds to these glucose molecules.
Glucose is sugar, by the way.
You're correct. So this causes sleepiness. So you can use that to your advantage to maybe have a heavy pasta meal or a French toast meal like I do.
You have French toast?
Correct.
Wow.
Correct. So
we're fancy. We're also chef. Chef over here.
I have an inverse eating schedule where I have most of my protein in the morning and then most of my carbohydrates at night. As a side note, we'll go into another podcast is that eating protein in the earlier part of the day has been shown to train your body towards hypertrophy training, increasing hypertrophy of the muscles. So that's another reason why I do that. But anyway, for the point of sleep, increasing your carbohydrate intake before bed, not immediately before bed, but within the time frame of 2 hours, having that increase of carbohydrates has been shown to increase sleepiness. Obviously, as anyone can attest to after eating a Thanksgiving meal.
Hey, those nap on the couches right after you get done having some turkey, having some stuffing. Oh, they're the best.
Oh, and another side note.
Oh, okay.
Turkey. So turkey, why it makes you sleepy actually is because it contains tryptophan. Tryptophan is another amino acid, but it's also the precursor, meaning the chemical before the conversion to melatonin. So
wow.
There you go. Yeah. Another crazy fun fact.
So throughout this podcast, because this is episode 1, right? We have more coming up, and you can tell there are some times when we want to reach into certain topics, but we can't because we have to save it for another podcast. I think this is actually a good wrap-up point, but I want to go back and just give a 1-minute overview of everything we've talked about, okay? So we've talked about the generalities of sleep, right? What happens during sleep, how it works. Then we talked about melatonin, its impacts, and little known facts about the hormone. Then we talked a little about caffeine, separated the difference between drugs and external factors and internal, such as hormones. Then we went into a little bit about nutrition. That sounds like a great way to conclude. And I hope we're able to give you guys some information that maybe you didn't already know. I also want to, since this is episode 1, let's give an overview of what's coming up. So here's how it works. So there's a lot of work that goes into the science podcasts. So what we're going to do is every other week, there will be a science podcast. These will be a little bit longer. Then, so this week coming up, we will have 2 episodes drop. They're going to be shorter. You can listen to them in the morning and the evening, get along with your day. And they will be focused on some questions that people have and some lessons that we've learned in the gym or through fitness and nutrition along our path. And so, without further ado, Michael, do you have any closing thoughts?
Yeah, I want to say get your caffeine in check. Push it off as long as possible. If view the sunrises and the sunsets. Look to supplements if you need help. Increase your carb intake at night. And always try to get 6 to 8 hours of sleep to get the maximum amount of REM cycles.
Awesome. Well, if you stuck around this long, I'll disclose it to you guys. We recorded this podcast on Sunday, but we didn't hit record. And so if there were a few things where maybe we where you're like, what? That's the reason why. We had, and it honestly, it's all part of the journey though. And it's one thing that I've learned through fitness is failure is inevitable. So you might as well fail on your first time. That way you get it out of the way. So yeah, let's kick it off. Guys, thank you for joining us. We really appreciate it, and have a great night.